class 8 students for physics, and we'll be doing the same topic, that is your heat transfer. And today we'll be studying furthermore about heat transfer. So in the previous class we discussed first with introduction, then we did the effects of heat, then we discussed about the effect of temperature, then we discussed about vaporization, that is your evaporation, and boiling and the differences. So today we'll be talking about thermal expansion. Okay, we'll be talking about thermal expansion. Now thermal, means thermal, the word means heat, isn't it? So, and we know that because of heat there's always expansion. So heat, when a body absorbs heat, it expands, and if a body loses heat, it contracts. So we know that concept, heat causes expansion, and if heat is lost, then it causes contraction. So we'll be discussing about that today, more in detail, okay? Now, before we move on to the exception, let's talk about thermal expansion in solids. Okay, how do solids get affected? How does solids expand, and why does solid expand when it absorbs heat? So what happens? A solid has a definite shape. The molecules of a solid are tightly packed. Okay, the molecules of a solid are tightly packed, and they are in a pattern, they follow a pattern, so they are tightly packed. Now what happens when this solid particles, they get heated? So if you heat any solid particles, okay, when you heat a solid particle, the particles absorb heat. When they absorb heat, which is in the form of energy, heat is a form of energy, isn't it? So when they absorb heat, they gain energy. And when they gain energy, their kinetic energy, the kinetic energy increases. That means they start vibrating very fast. They start moving very fast. Okay, and the amplitude of their vibration becomes more. That means if they were vibrating at this height initially, when they absorb heat, they start vibrating at a larger distance. Okay, so they start vibrating very fast and with a larger amplitude. So when they cover larger amplitude, so there comes a point when they break the intermolecular force of attraction. That means the force of attraction between the two molecules. Okay, if this molecule has been vibrating a lot, and say there was another molecule here, what is happening is it starts vibrating up, so what happens if it starts going to this direction? It's maintaining what is happening over here. The distance between the space between the two molecules are increasing. So the space between the two molecules is increasing, and if the space between the molecules increases, then the intermolecular force of attraction becomes weak. Okay, so when the force of attraction becomes weak, the molecules can easily move apart. So they start moving apart. So what happens? They start expanding. Okay, and the volume of the solid also expands. That means they cover more area. So if I heat any metal, okay, if I heat it and if it expands, though the expansion is not visible, isn't it? You might not see the expansion, but solids also expand when they get heated. Though the expansion is negligible, but still it gets expanded. Now, thermal expansion in solid. A solid has a definite shape. When a solid is heated, it expands in all directions. Hence, the length, area and volume all increase on heating of solids. The increase in length of a solid is called linear expansion, which we will be learning later in the same chapter. The increase in area is called superficial expansion, and the increase in volume is called cubical expansion. Okay, so all this linear expansion, superficial expansion and cubical expansion we'll be learning more in detail in the same chapter after this. Okay, first these are only introduction. First we'll do the introduction part, then we'll continue. Now, explanation of thermal expansion of solids on the basis of molecular motion. So I told you what happens when the particles gets heated. They start vibrating faster, which means they start vibrating at a higher amplitude, and the force of attraction becomes weak. the space between the particles become more and the particles occupy more space. Okay. So on heating a solid, the average kinetic energy of molecules of the solid increases. They start vibrating about their mean position with a large amplitude. The result is that the mean position changes such that the intermolecular separation between the molecule increases. Thus the solid expands equally in all directions, which means after getting heated, the same solid becomes a little bit expanded. Okay, which means what has increased? Its volume has increased. It has occupied more space. So here an example, a demonstration experiment is done, and let us discuss the experiment. Okay, we might not be able to do the experiment here, but we can discuss that. So for that, what you need to do is you need to take a stand which has a ring. Okay, and the ring should have, through this ring, a solid ball should easily pass. This is before heating. Okay, before heating. So let us take an iron ball. You can take a ball made up of iron. So this is your iron ball. This is your ring. So this metal ball, okay, before heating, it can easily pass through the ring. Now, you heat the metal ball for some time. Okay, you heat the metal ball you heat it. So after heating the ball, what happens is, what will you observe is this ball will not enter through this ring. Okay, the same ball will not enter through the ring after heating. What does it prove? It proves that the ball has expanded. Though we don't see the difference in size. Okay, we might see the size is same, but still there will be expansion. So though the expansion in solids are negligible, which means the expansion in solids are not as visible, okay, we don't see much difference, but still it doesn't mean that the solids do not expand. They do expand. So all solids, liquids and gases expand when they get heated. So this is an experiment to show that solids also expand, and that is your thermal expansion. But there are some exceptions. Okay, there are some exceptions for thermal expansion. One is your water, and water generally between 0 to 4 degrees Celsius they don't expand. Okay, between 0 to 4 degrees Celsius water do not expand. So that phenomenon of water, okay, that character of water is called anomalous expansion of water. So between 0 to 4 degrees Celsius, the volume of the water doesn't increase. Even if you heat it, okay, you're heating the water, still its volume will not increase. After getting heat, after absorbing the heat also, the water between 0 to 4 degrees Celsius will not expand. It will not show any expansion. And that is your unusual character of water, which is called anomalous expansion of water, which is not mentioned over here. So I'm not going into detail. So these are only for your references. So please remember, between 0 to 4 degrees Celsius, water, its volume doesn't increase, it doesn't expand. Okay, it doesn't show any change, despite being heated, despite being the change in temperature from 0 to 4 degrees Celsius. And that unusual character of water is called anomalous expansion of water. Another example is silver iodide between 80 degrees Celsius to 141 degrees Celsius. So another chemical which is called silver iodide, it doesn't show any change between 80 degrees Celsius to 141 degrees Celsius. Even if it's heated between 80 to 141, there will be no expansion seen. Then silica, below minus 80 degrees Celsius, it will not show any change, which means it will not show any contraction. So So these are the exception. Okay. They contract on heating and expand on cooling in the given range of temperature. Okay, we have an experiment 2 also over here, and we don't need to do that experiment number 2. You can read it on your book, from your book itself. Okay, so just understand this is your thermal expansion, and we just introduced you thermal expansion. We did one experiment. We discussed one experiment to show that heating causes expansion in solids as well. Okay, though the expansion is not so visible. And next we'll be discussing about. Okay, and as we discussed that the linear expansion, thermal expansion are of 3 types. Okay, thermal expansion are of 3 types. One is your linear expansion, so expansion in length. Second is your superficial expansion, which means expansion in area, and the third one is cubical expansion, which means expansion in volume. Okay, so linear expansion, thermal expansion are of 3 types. These we are talking about solids over here, thermal expansion of solids. Okay, so thermal expansion 3 types. One is your linear expansion, the other one is your superficial expansion, the third one is your cubical expansion. Linear expansion, increase in length. Increasing length. The second one is your superficial expansion, which means increase in area, and the third one is your cubical expansion, which means increase in volume. So, if a solid increases in length, if the length of the solid increases, we say linear expansion. If the area of the solid increases after getting heated, then we say superficial expansion. And if the volume, the entire length, breadth and height changes for a solid, then we call it cubical expansion. Okay. So the first one we'll be discussing about is linear expansion. Okay. So if a solid, say if this is an iron rod, a metal rod, okay. If this metal rod, you heat it, say this is your metal rod, and if you heat it for quite some time, so if you heat it for quite some time, what will you find is, before heating, you need to measure the length of the rod. Say the length of the rod is 10 unit, okay. If the length of the rod is 10 unit, after some time, after heating it, after some time, you might find it to be 10.5 or 11, depending upon the heat absorbed and depending upon how much time it has been absorbing the heat. So, if the length of the rod increases, we call it linear expansion. So, when a solid is in the form of rod is heated, only the linear expansion is effective, which means if a rod is heated, only its length will increase. So that means the increase in length of a metal rod on heating depends upon the 3 factors. One is original length of the factor, next is increase in temperature, and the third one is material of the rod. Okay, now dependence on the original length of the rod. So first one, we are only discussing about linear expansion. That means increase in length. Now linear expansion further depends upon 3 factors. Okay, this depends upon 3 factors. One is original length of the rod. The second one is increase in temperature. And the third one is material of the rod or material of the object. Now original length, if we are talking about this original length, Okay, if we are talking about original length, say you take two rods. One is 5 units, the other is 6 units. So you take two different rods. Okay, you take two different rods, one longer and the other one a little bit shorter. And the volume is same, area is same. Sorry, not the area, the volume. Now, if you provide them with the same temperature, heat, okay, if you supply same amount of heat for both the rods, okay, if you supply the same amount of heat for both the rods, this and this will not increase by the same length. Which means the longer rod will expand little bit more than the shorter rod. Okay, which means if you supply the same amount of heat, despite that, this will be longer compared to this one. So this is what original length means. If the original length of the rod, if you compare the rod, if it's short, the one is shorter, the other one is longer, and if you apply the same amount of heat, okay, the amount of heat is same. If you supply the same amount of heat, this 6 unit, the one which is longer, will expand more than the one which is shorter. The second one, if you take two rods of the same length, okay, if you take two rods of the same length, so this is your 5 units and this is your 5 units. If you take two rods of the same length but supply them with different amount of heat, say you will apply less heat here and this one you supply more heat. So the one which absorbs more heat will expand more. Okay, the one which absorbs more heat will expand more than the one which absorbs less heat. That is your second one, dependence on the increase in temperature. And the third factor is depending upon the material. So if you heat iron and steel and you supply the same amount of heat. Okay, if you supply the same amount of heat, what will happen? They will expand at a different, in the same amount of heat, they will expand different ways. I mean, one will expand more than the other. Okay, so if you heat a copper and an iron, so which one will expand more? Copper, of course, because copper are good absorbers of heat, isn't it? So they are one of the best conducting materials. That's why we call them one of the best conducting materials, right? So when you compare them, so this is what it means material. So if you take two different materials, they will expand in a different way with the same amount of heat. You supply the same amount of heat, but the two different substances will expand differently because they are different materials. If you supply the same, if you take two identical rods of the same material, and in one you apply less heat and the other one you supply more heat, the one which absorbs more heat will expand more. And if you take two rods of different lengths, okay, but the same material but different lengths, and if you supply the same amount of heat, if you supply the same amount of heat also, the one which is longer will expand more than the one which is shorter. So this is what it means, linear expansion. So this one we'll discuss more in detail in the next class. We have this coefficient and all, so we have this much for today, and we'll be discussing further more in the next class. Till then, have a good day.